Hello everyone and welcome to the lecture on AWS App2Container. So this lecture will contain all these topics. What is AWS App2Container? How App2Container works? Accessing AWS through App2Container, operating system compatibility, deployment feature support, getting started, App2Container automation runbook. So what is AWS App2Container? AWS App2Container is a command line tool that helps modernize .NET and Java applications by converting them into containerized applications. App2Container simplifies migration by taking inventory and analyzing your existing applications, creating Docker containers that include the application dependencies. The tool generates deployment templates for you that are based on AWS best practices with known values already filled in. After reviewing the templates, App2Container helps you register your containers to Amazon Elastic Container Registry, deploy it to Amazon Elastic Container Service or Amazon Elastic Kubernetes Service, and set up CI/CD continuous integration continuous delivery pipelines using AWS CodeStar. How AWS App2Container works? App2Container generates container images from the applications running on Windows or Linux servers. These containers are compatible with Open Containers Initiative (OCI), even for commercial off-the-shelf COTS applications. You don't need the application source code to containerize it. App2Container can be used directly on application servers or through a worker machine. The tool creates a list of all running ASP.NET on Windows and Java on Linux applications that are candidates for containerization. It also analyzes the runtime dependencies of the applications. App2Container extracts the necessary files for containerization and creates a Docker file. It initiates the container build and generates artifacts for deployment on AWS services like Amazon ECS, Amazon EKS, or AWS App Runner. App2Container can upload AWS CloudFormation resources to an Amazon S3 bucket and set up CloudFormation stack. It can also create a CI/CD pipeline using AWS Code Pipeline for automating container building and deployment. Accessing AWS through App2Container. So when you initialize App2Container, you provide it with AWS credentials. This allows App2Container to do the following. First, store artifacts in Amazon S3 if you have configured it to do so. Second, create and deploy application containers using AWS services, which I talked about, ECS, EKS, and AWS App Runner. And create CI/CD pipelines using Code Pipeline. Now we'll see the operating system compatibility. So we have the supported operating systems, and these include Ubuntu, CentOS, Red Hat Enterprise Linux, Amazon Linux 2, and Amazon Linux 2023, and on Windows Server 2016 and later. Container host, any supported operating system. Major kernel version must match container image, and for Windows it should be 2016, 2019, 2022. OS version must match the container image. Application types, so it includes Java applications on Linux, and on Windows it supports .NET and IIS.NET application. Supported frameworks, it includes JDK 1.8 and plus, application server like Tomcat, Tom Enterprise Server, and JBoss Standalone. And on Windows, .NET Core, .NET 5 to 9, and .NET Frameworks 3.5 and 4.x. Unsupported features, so high availability clusters is not supported, and on Windows, IIS apps using files/registries outside IIS web application directories. Additional requirements, so Docker must be installed and it should be 17.7 plus, kubectl up to 1.3 for EKS if you want to deploy it to EKS. And for Windows, these are the minimum requirement. Docker must be installed on that machine, on the host machine, kubectl, if you want to deploy it to EKS. And for Windows, IIS must be installed, and PowerShell 5.plus or 1 or 6 plus. Then let's deployment feature. What features are supported? So first one is modifying the memory usage. And if you deploy it to Linux on this platform like ECS, Elastic Container Registry, Fargate, so it's supported. You can modify the memory. EKS also. For App Runner, no. And if it's a Windows based ECS, so all three are supported. Modify CPU usage. So again, for ECS and EKS, it's supported for Linux and Windows. If the target platform on ECS and EKS, all three are supported. Load balancer types. So what load balancer types are available? For ECS, application load balancer. For EKS, you have application load balancer available, network load balancer with Nginx. For App Runner, there is no support for any load balancer. And for Windows based deployments, both application load balancer are supported. And for EKS, you have support for application load balancer, network load balancer with Nginx. Okay, reusing VPC. So it's supported for ECS, Fargate and EKS. For App Runner, it's not supported, that you cannot reuse the VPC. For Windows based application, all three, it's supported for all three services: ECS, ECS on EC2 and EKS. Reuse cluster, so it's supported. Again, same story over here, but App Runner, it's not supported. Then for Windows based, all three are supported. Fire lens logging, so it's a special feature. So supported for only for ECS. For EKS, it's not supported for Linux based, and rest all is not supported. And GMSA for Active Directory, it's specific to Active Directory, and it's not supported for anything but except Windows based ECS and EKS. That too on EC2 deployments, it's supported. And deploying complex .NET apps. For ECS, it's not, because it's a .NET based application, so on Linux it's not supported. But if the target host is deployment is Windows, all three are supported: ECS, Fargate, ECS and EKS on EC2. So this is the typical workflow and how to get started. So first, you make sure that you have Docker running on the machine. So you can just do a Docker run and or make sure you run a hello world and it should be up and running. Then you can kill it. Then you can download the App2Container binary. So this is specific to Linux. Then you can just do a tar, untar the binary tar.gz file, and then you can just do a sudo install. After that, on each server where you have installed App2Container, run the particular command App2Container init and run the inventory command. Then it will give you a output something like Java app ID, and that will have process ID, command line and some more ID also. There will be some specific ID also. So once you get the app ID, Java app ID, you will locate the application ID for the application to containerize from the JSON output in the previous command. Then you can just do a sudo App2Container analyze and the Java app ID from this particular previous output, and to containerize the application on the application server. So same things. So analyze, it will create an inventory, and finally you can say containerize, same command, only this is analyze, this is containerize, and finally you run the generate app deployment command to deploy the application on AWS. So by default, it will go to ECS, Elastic Container Service, if you don't specify like EKS or ECS with EC2. So this is default is Elastic Container Service with Fargate, which is a serverless compute. And it will, so before that, it will already like attach with your AWS credentials, and then it will know which AWS account to connect to and where to deploy your application on ECS. Okay, last is App2Container Automation Runbook. So this is specific case if your applications are running on AWS EC2. So previously I talked about applications running on premises or your own Linux server or on your data center. This is if you want to migrate from applications running on EC2 to the ECS or EKS. So then you can run App2Container also, and there is the automation runbook. So AWS App2Container offers automation runbook called AWS App2Container /replatform applications. This runbook is designed to be used on your Amazon EC2 instances, and it's available via Systems Manager service. This runbook automates several key steps. First, it installs the App2Container tool. Then, it automatically goes through the initialize, analyze, and transform phases, which are essential for replatforming your supported applications. If you want, the automation process can also handle pushing the resulting containerized application to Amazon Elastic Container Registry. To be able to use this automation runbook, you need to have the necessary access to AWS Systems Manager. Automation is a feature within Systems Manager. So if you have access from there, you just run it. So it's just cloud-based. You run that particular runbook option and it will do all the rest for you. Before you start the automation, you need to have an Amazon S3 bucket. This bucket will be used to store the various artifacts that are created during the containerization process. And it is important that this S3 bucket is in the same AWS account and the same AWS region as the Amazon EC2 instances you are planning to containerize. You also need to have a specific IAM service role set up, and this role grants the automation capability of AWS Systems Manager the necessary permission to run the automation tasks on your behalf within your AWS environment. Finally, your Amazon EC2 instances themselves need to have an IAM role attached to them. This role must grant the necessary permissions that allow the automation process to perform actions on these target EC2 instances. And that's all. Thanks for watching.